Thanks everyone for your attendance and the interest in Astronergy's N7 and N7s innovations. I will first have a company introduction to get people familiar, and then I will talk about the key technology trend in the current market. After that, I will introduce the advanced technologies applied to our Astro N7 and N7s, and finally a summary. Well, Chint Group has a long history and is a global leader in the smart energy solutions with three key segments: green energy, intelligent electric, and smart low carbon. Astronegy was founded in 2006 and is a subsidiary of the Chint Group. It is the distinguished manufacturer specializing in intelligent photovoltaic cells and modules, recognized as the Tier 1 PV modules manufacturer by Bloomberg. Here are some honors that Astronegy has won over these years: the best yield performance for bifacial modules by PV Magazine Test, TUV Rainland All Quality Matters, PVEL a top performer for 8 times, RETC highest achiever, and so many else. Astronegy is expected to achieve a TOPCon module production capacity of 75 gigawatt this year, with 85% dedicated to TOPCon technology. In terms of global presence, Astronegy has one manufacturing base in Thailand for wafer, cell, and module production, and there are more coming. Between 2020 and 2021, Astronegy module shipment increased slowly by only 0.4 gigawatt, but it kept doubling in the following years and finally will achieve 50 to 60 gigawatt this year. In the second sector, I will go through the key technology trend and some major technologies on the market. But two well-known third-party institutions, PV InfoLink and Bloomberg NEF, have estimated the market shares of different cell technologies according to their findings. TOPCon is expected to dominate the market this year, taking up more than half of the market share. At the same time, the market shares of HJT and XBC are gradually increasing. Here are 4 kinds of cell technologies with great potential to become popular products now or in the near future. Each of them has its own advantages, but also certain limitations that need to be improved. Let's start with the TOPCon, which is the main product in the current market. Compared to PERC, TOPCon has a series of advantages like high bifaciality, mature technology, and high compatibility in the industrial chain. One shortcoming is that TOPCon cells require a high temperature process and more fabrication steps compared to HJT. On the basis of HJT, TOPCon, HJT has a higher bifaciality and a better temperature coefficient. There are some obstacles in the process of mass production, such as high costs, completely new equipment and process for manufacturing, and so on. XBC is more efficient because there are no obstructions on the front surface, which also makes XBC more aesthetic. Since all the connecting wires are at the backside, more area is covered and the bifaciality will be low. Perovskite tandem is a special technology stacking multiple layers and will theoretically reach over 30% efficiency. Reasons why this kind of cell not ready for the market include reliability issue, production difficulty, and of course the high cost. After all, according to the current situation, TOPCon is the most cost-effective for mass production. Before 2021, the wafer size was smaller squares. Since then, the size started to become larger, such as 182 and 210 millimeter side length. This is because the larger wafer area, the higher power of each wafer. The rectangular silicon wafer is a product of the module enterprises continually explore. After considering the entire industrial chain together, the rectangular wafer size is believed to be an appropriate choice. Leading enterprises have all made deployments and started promoting them. There are several advantages of modules using rectangular wafers comparing to those with regular 210 or 182 wafer sizes. Due to the larger wafer size, larger module size, and heavier weight of 210 times 210-66 module, it is more likely to occur risks related to mechanical performance, transportation, unpacking, and installation. Regarding to 182-78 module, there are relatively more cells, leading to higher voltages and smaller string sizes. Therefore, modules using rectangular wafer rise in response to the proper time and the conditions with a balance between these two models. It has a relatively high power, medium module dimension, moderate current, and low voltage. A financial advantage of rectangular wafer is they can optimize the use of container space and reduce the transportation cost. Since the rectangular wafer size is longer and the corresponding module size is longer, there will be less empty used space when delivering the modules with the rectangular wafers. Additionally, there will be 4.3% or 18 kilowatt more power per container, and the final sea freight cost will be saved by 0.04 cent per watt. Okay, now we will move on to the advanced module technologies of our Astronegy products, N7 and N7s. Astronegy has two main product series utilizing rectangular wafers, N7 and N7s, designed for utility scale projects and residential properties respectively. And the N7s has two models with different cell quantities. And in this part, I will introduce technologies applied to them. Let's begin with an overview of ASTRO N7 module, which includes 5 major technologies: rectangular wafer, super multi-bus bar, TOPCon 4.0, 2-layer higher transmittance glass, and the light reducting film. ASTRO N7 offers several advantages over other mainstream square wafer modules. First, ASTRO N7 has a VOC, or open circuit voltage, about 6% lower than 182 millimeter modules with 72 cells, which means it can accommodate 2 more pieces per string within 1500 volts limit. Compared to the 210 modules that are 1303 millimeters wide, ASTRO N7 has a narrower module width, allowing 1 more string per tracker within a 100-meter tracker length limit. This higher module quantity per tracker increases the power output per tracker when using ASTRO N7. Therefore, with the same project capacity, ASTRO N7 can reduce costs associated with the drive and the control systems. Overall, ASTRO N7 is expected to have the lowest levelized cost, or LCOE, due to these advantages. Apart from the utility scale product, Astronegy has offered residential solutions with ASTRO N7s. There are 2 models available with different cell quantities. The 54 cell model has an area less than 2 meters squared to comply with the regulations in Germany, and weighs about 21.5 kilograms, making it easy for 1 adult to handle. And the 60 cell model is designed for the 3 kilowatt policy for distributed systems in Europe. Both models, both models utilize TOPCon 4.0 and high efficiency cells, 0 bus bar, and tiling film technology, as well as the 191 millimeter rectangular wafers. The ASTRO N7s series boasts the highest mass production power and efficiency for modules of the same size except XPC. Its double glass design makes it more resistant to dampness and humidity, ensuring a 25-year warranty. Additionally, its zero busbar and uniformly full black appearance make the modules aesthetically pleasing on the rooftops. The primary technology applied to ASTRO N7s is the zero busbar and the titanium film technology. The interconnection between them can be achieved by prefixing soldering ribbons with the encapsulation film and the cells in one-step process. The OME contact is formed during the lamination with the process temperature smaller or equal to 150 degrees Celsius, which lowers the thermal stress. And this end up with a higher power output because 20 thin soldering wires shorten the current transmission path and reduce the series resistance. ZBB soldering wire results in smaller shading area than 16 bus bars and reduces the optical loss. Eliminating the cell spacing between neighboring cells in a cell string reduces the cell-to-module losses and boost up module power output. This interconnection can also provide a better reliability. Astronergy's DBB plus TF technology introduces finer and more solder wires and a low-temperature soldering process, which enables a flexible electrical connection between solder wires and cells, reducing the risk of cell cracks. Soldering flux is eliminated in the process, avoiding the erosion of cell fingers by the organic acids in the flux, thus improving the DH performance. Well, here comes the final summary. First, the PV industry is currently undergoing a technological shift from PERC to N-type technology with a focus on TOPCon and HJT. At present, TOPCon clearly dominates the market due to its low initial investment, mature technology, and high compatibility with the previous production lines of PERC. The PV industry is currently embracing a new wafer type, rectangular wafer, with a focus on two main formats, 210 times 182 millimeters and 199 times 182 millimeters. Due to the area limitation of solar projects, adopting this new rectangular wafer can optimize shipping container space, reduce shipment costs. And finally, ASTRO N7 and N7s use the most advanced TOPCon cell and module technologies with optimal rectangular wafers, advanced TOPCon 4.0, super multi-busbar, light reducting film, and high transmittance glass to make the modules more powerful and reliable. Well, that is all for my presentation. Thanks for your attention.
Astronergy for a greener world.